Ever wondered what principles guide the work of software engineers? Well, just like architects or doctors, software engineers also adhere to a set of principles. These principles are not just random rules, but rather, they are carefully crafted guidelines that help engineers navigate the complex process of building software. They ensure that the software is robust, maintainable, and efficient. These principles range from DRY, which stands for Don't Repeat Yourself, a principle that aims to reduce code duplication, to the SOLID principles, a collection of 5 principles that aim to make software designs more understandable, flexible, and maintainable. There's also the KISS principle, an acronym for Keep It Simple Stupid, which promotes simplicity in design and implementation. Other important principles include modularity, abstraction, and consistency. Now let's delve into these principles and see how they shape the work of software engineers. First up, we have the DRY or Don't Repeat Yourself principle. This principle is a cornerstone of software engineering, aimed at reducing duplication in code and making it more maintainable. Simply put, DRY encourages us to avoid writing the same logic or data in multiple places. Imagine you're writing a book. If you have to repeat a phrase or sentence several times, wouldn't it be easier to just write it once and then refer back to it when needed? The same goes for code. By reusing the same piece of code, you not only save time, but also make your code cleaner and easier to read. Now let's consider an example. Suppose we have a class, employee, with a method, calculate_bonus, and another class, manager, which also has a calculate_bonus method. Both methods have similar functionality, but slightly different logic. This is a clear violation of the DRY principle. Instead of repeating the method in both classes, we could have the manager class inherit the calculate_bonus method from the employee class and then override it only when necessary. This way, we eliminate duplication, making the code more concise and easier to maintain. The DRY principle is not just about reducing repetition, it's about making your code more efficient, more readable, and ultimately more enjoyable to work with. So remember, keep it dry and avoid unnecessary repetition in your code. Next, we have the SOLID principles, a cornerstone of object-oriented programming. These 5 principles provide a structured approach to designing software that is easy to understand, flexible, and maintainable. First up is the Single Responsibility Principle, or SRP. This principle states that a class should have one and only one reason to change. Imagine you're designing a system for a library. You might have a book class that includes methods for checking out and returning books. But what if you also included methods for calculating late fees? Now, your book class has 2 reasons to change: changes to the book's attributes and changes to the late fee policy. By enforcing SRP, we would separate these responsibilities into 2 classes, keeping our code organized and easier to maintain. Next is the Open-Closed Principle, or OCP. This principle encourages us to design our classes so that they can be extended, without needing to modify the class itself. Let's consider a shape class with a method to calculate area. If we add a new shape, we'd have to modify the shape class to accommodate this. But with the OCP, we would design the shape class to be open for extension, perhaps by allowing new shapes to inherit from it and override the area method. Moving on, we have the Liskov substitution principle, or LSP. This principle states that derived classes must be substitutable for their base classes. In other words, if a method expects an object of the base class, it should work seamlessly with objects of the derived class. For instance, if a printer class has a method to print a document, a derived color printer class should also be able to print a document without causing any issues. Fourth on our list is the Interface Segregation Principle, or ISP. This principle advises us to create fine-grained interfaces that are client-specific. Instead of having one large interface with many methods, we should break it down into smaller, more specific interfaces. This way, classes that implement these interfaces aren't forced to depend on methods they don't use. Finally, we have the Dependency Inversion Principle, or DIP. This principle suggests that high-level modules should not depend on low-level modules. Both should depend on abstractions. Instead of a high-level car class depending directly on a low-level engine class, both should depend on an iEngine interface. This makes our design more flexible, allowing us to swap out the engine with a different implementation without affecting the car class. The SOLID principles guide us in creating software that is easy to manage and maintain. By applying these principles, we can create systems that are robust, adaptable, and most importantly, easy to understand. Moving on, we have the KISS, or Keep It Simple Stupid principle. The beauty of this principle lies in its name itself. It encourages us to keep our designs and implementations as simple as possible. You see, simplicity is the ultimate sophistication, especially in the world of software engineering. The KISS principle nudges us away from complex solutions and unnecessary complications. But why is simplicity so important, you might wonder? Well, simple code is easier to read, understand, and manage. It's less prone to bugs and errors, and it's much more maintainable in the long run. It saves time, energy, and resources. Moreover, it's easier to test and debug, making it a win-win situation for everyone involved. So, the next time you sit down to write a piece of code or design a system, remember the KISS principle. Avoid complexity, embrace simplicity. With the KISS principle in mind, always strive for simplicity in your code. Now, let's talk about modularity and abstraction. In the realm of software engineering, these two concepts play pivotal roles. Modularity is the practice of dividing a software system into separate, independent modules. Picture it as breaking down a large puzzle into smaller, more manageable pieces. Each module carries out a specific function and can be worked on independently without affecting the others. This approach not only accelerates the development process, but also makes debugging and maintenance easier. It's like working on one piece of the puzzle at a time, rather than trying to fit the entire thing together all at once. On the other hand, abstraction is all about hiding complexity. Just as a car driver doesn't need to understand how the engine works to drive the car, software users don't need to know the intricate details of how the software operates. We achieve this through abstraction, which hides the complex details and presents only the functionalities to the user. It's like seeing the completed puzzle without having to know the effort and process that went into putting it together. Both modularity and abstraction help in dealing with complexity by breaking it down into manageable, understandable pieces. They are vital tools in the hands of software engineers, helping to create efficient, maintainable, and user-friendly software. By applying modularity and abstraction, we can make complex systems more manageable. Lastly, we have the principle of consistency. Now think of consistency as your best friend when it comes to coding style and graphical user interface, or GUI design. It's the unsung hero that ensures your code is easy to read and your interface is intuitive to navigate. In coding, maintaining a consistent style, like indentation, naming conventions, and overall structure, can make your code significantly easier to read and understand. It's like reading a well-formatted book rather than a jumbled manuscript. This consistency aids in reducing errors, speeding up the development process, and making collaboration a breeze. Similarly, in GUI design, consistency ensures a seamless and intuitive user experience. It's about maintaining the same layouts, icons, and color schemes across the interface. This way, users can predict how to operate the software without constantly referring to a manual. In a nutshell, consistency in your software can greatly enhance user experience and readability. So there you have it, the principles that guide the work of software engineers. We started with the dry principle, urging us not to repeat ourselves, to keep our code clean and maintainable. Then, we moved on to the solid principles, the cornerstone of object-oriented software design. These principles ensure our classes are well-structured and our systems are easy to extend and maintain. Next, we tackled the KISS principle, a reminder to keep things simple and avoid unnecessary complexity. We then explored the concepts of modularity and abstraction, tools that help us break down complex systems into manageable parts. And finally, we discussed the principle of consistency, which helps us create user-friendly interfaces and maintainable code. These principles are not just rules to follow, but tools to help us think critically about our design choices. By understanding and applying these principles, you too can create high-quality software. Thanks for watching. Thanks for